Hello, in this video, what we're going to do is apply the formula of finding the volume of a parallelepiped. So a parallelepiped is a three-dimensional parallelogram. So this is a parallelepiped. And if, parallelepiped, if A, B, and C, these vectors all lie on the same plane, then you don't really have you don't have a solid at all, and the volume will be zero. All right, so the volume of a parallelepiped is given by V equals the absolute value of the triple product. And in fact, you can change the order of A, B, and C, and that will possibly change whether your answer is positive or negative, but when you take the absolute value, you get a positive number anyway. So it doesn't matter which vector you put in first. Now what we see is that if we use the volume formula, and the volume, if this formula gives 0, then what we're going to conclude is that these vectors A, B, and C all lie in the same plane. And we start off by saying that we're going to show that they're coplanar. So we already know, they're telling us it's coplanar. Now this is a little proof. We're going to show they're coplanar by finding the triple product and seeing that the triple product is 0. So in fact, these vectors do not apply for this figure. So in our situation, so we want to, well, I don't know. I was about to say we want to show A, B, and C are coplanar. It says that in the directions. So we want to show that volume, which is absolute value A dot B cross C, is equal to 0 for these particular vectors. All right, and if it's 0, we will conclude that they all lie in the same plane. And let's go ahead and write down what this triple product is. Well, the triple product, leaving aside the absolute value for the moment, is the triple product is the cross product of B and C dotted with the vector A. There is we showed that this is the same thing as finding the determinant of the matrix that consists, consists of the vectors A, B, and C as rows. So that can be shown. And so in this particular case, I need to look up ahead and look up and see what A is, sort of zoom out. A is 1, 4, negative 7. B is 2, negative 1, 4. And C is 0, negative 9, 18. So apparently in this particular problem, this determinant will equal 0. But, in general, if I just pick three vectors, especially if you use some random number generator, you're not going to get 0. Like they shouldn't be coplanar. Okay. Maybe it'd be very unlikely if you just pick those randomly that's what you get. Okay, the numbers randomly. Anyway, so let's just check this out. How are we going to find this determinant as we expand across the first row? And so what it is, it's 1 times the 2 by 2, 1 being the first entry here. It's 1 times the 2 by 2 determinant found by crossing out, scratching out the row and columns that the 1 has. So I have negative 1, 4, negative 9, 18. And then I'll subtract, and it always goes plus, minus. And so I subtract the next entry on the first row, which is 4. And I multiply by the 2 by 2 determinant, which is found by scratching out the row and column that contains that 4. And so I therefore will get 2, 4, 0, 18. And then I add, again, it always goes plus, minus, plus when we go across the first row. So I add negative 7 times that the 2 by 2 determinant of the matrix found by scratching out the first row in the third column. So that would leave 2 minus 1, 0, minus 9. And so pushing ahead then, when we to find these determinants, they're 2 by 2 determinants, I multiply across the main diagonal and I get negative 1 times 18, and I subtract along this other direction and I get negative 9, 4. Put a big parentheses around that, minus 4, and I multiply across the main diagonal again and get 2 times 18 minus subtracting the other direction, subtracting this way, minus 0 times 4, plus negative 7, and now I have 2 times negative 9 minus 0 times negative 1. So it's multiplying across the main diagonal and then subtracting the opposite diagonal. I don't know if that's opposite, but they have that one right there. Okay, so then it's negative 18 plus 36, just doing times tables here. 2 times 18 is 36 minus 0. And then my handwriting is a little bit messy here. Okay, minus 7, negative 18 minus 0. So this gives 18 minus 4 times 36, which is 144, plus 7 times 18, and that's going to give, I better get this right, okay, 126, and we'll see that 18 plus 126 is in fact 144. So 144 minus 144 is 0, and so there we go. So therefore, this shows that the vectors A, B, C are coplanar, which means they all lie in the same plane. Okay, so again, that parallelepiped that's shown does not correspond to those vectors, and I don't know what we could call them, a different letter or something, but this is not the parallelepiped. Our parallelepiped, for our parallelepiped, A, B, and C all lie in the same plane. Okay, so that's all. Okay, thank you, bye.